Good afternoon, dear colleagues and guests. Today it is the 8th of April 2022, 12 p.m. according to Moscow time. Allow me to consider open the meeting of the Dissertation Council for the defense of Anna Kuzminova's dissertation for the degree of the candidate of Chemical Sciences in the scientific specialization 142 Analytical Chemistry on the topic optimization of evaporation and nanofiltration processes by creating novel polymer membranes modified with metal organic frameworks. At the beginning of our meeting, we announced technical break number 1. Distinguished guests and colleagues, the technical break number 1 is finished, and we continue our meeting according to the order of St. Petersburg University. Alexander Gnotov, dated from the 7th of February 2022, number 756/1, me, Lyudmila Yermakova, Doctor of Chemical Sciences, Senior Research Worker, Professor of the Department of Colloid Chemistry, St. Petersburg University, was appointed the chairperson of this dissertation council, and by the same order, the members of the dissertation council were approved. Let me introduce them. Mr. Semyonov, Doctor of Physical and Mathematical Sciences, Professor of the Department of Analytical Chemistry, St. Petersburg University. Alexander Volkov, Doctor of Chemical Sciences, Deputy Director of Topchev Institute of Petrochemical Synthesis, Russian Academy of Sciences, Head of the Polymer Membrane Laboratory. Mikhail Goikhman, Doctor of Chemical Sciences, leading research worker in the Laboratory of Polymer Nanomaterials and Compositions for Optical Media, Associate Professor of the Institute of Macromolecular Compounds, Russian Academy of Sciences. According to technical reasons, one board member, Andrei Ivanets, Doctor of Chemical Sciences, Minister of Education in Belarus, Scientific Supervisor in the Laboratory of Absorbents and Adsorbent Processes in the Institute of General and Inorganic Chemistry of the National Academy of Sciences of Belarus, correspondent member of the National Academy of Sciences, is absent today. Our applicant is also here with us, Anna Kuzminova. Also, there is a scientific supervisor of our candidate, Doctor of Chemical Sciences, Professor of the Department of Analytical Chemistry, Anastasia Penkova. I also inform you that audio and video recording of our meeting is being conducted, as well as live broadcast on St. Petersburg University website. Simultaneous interpretation of speeches from Russian into English is being provided. At this time, an email address is posted on the live broadcast of the meeting of the Dissertation Council, but during the meeting, all listeners can express their opinions and set questions to the applicant online concerning her dissertation and the current scientific discussion of her speech. And these questions will be forwarded to me by the technical services, and I will voice them during the discussion. Questions must be related to the applicant's presentation and the content of her dissertation, and the name, position, and place of work of the author of the question must be indicated. Questions that are not related to the scientific discussion, to the discussion of the dissertation, to the text and assessment of the dissertation, as well as anonymous questions, won't be voiced. In accordance with the procedure for awarding the academic degree of Candidate of Sciences, academic degree of Doctor of Sciences at St. Petersburg University approved by local regulations, hereinafter the procedure, a meeting of the Dissertation Council is considered eligible if at least 2/3 of the approved membership of the Council takes part in its work, but not less than 4 people. Our Dissertation Council consists of 5 people. 5 members are present. Thus, we have got quorum. Ask an employee of the Department of Supporting the Activities of the Dissertation Councils to issue an attendance sheet. The procedure of today's meeting of the Dissertation Council, with a total duration of approximately 2 hours, is the following. Number 1, a brief report of the chairman on the documents submitted by the applicant for a scientific degree and their compliance with the established requirements, answers to possible questions, about 5 minutes. Short presentation by the applicant for a scientific degree, reflecting the main points of her research, approximately 20 minutes. Questions to the applicant strictly according to her report, no more than 2 minutes per question. Answers of the applicant, about 5 minutes. Speeches of all members of the Dissertation Council in turn, with their assessment of the dissertation research, with a summary of their positions, with questions and suggestions for the dissertation, about 10 minutes per speaker. The speech of the chairperson, with the review, about 10 minutes, according to the agenda. Answers of the applicant for a scientific degree to questions, and comments of the members of the Dissertation Council, no more than 20 minutes. Open discussion, speeches at the request of those present at the defense, with a summary of their positions and or with specific questions and proposals for the dissertation, strictly on the topic of the research, no more than 2 minutes for everyone. At the same time, all interested people are requested to register in the registration form and completely introduce themselves before their performance. Presentation by the chairman of questions addressed to the applicant, which came in order to discuss her speech and scientific discussion on the broadcast of the meeting of the Dissertation Council of St. Petersburg University website. Written questions, which take more than 2 minutes, won't be voiced. Answers of the applicant to these questions. Then, speech of the scientific supervisor of the applicant, no more than 3 minutes. Then, discussion of the results of the defense by the members of the Dissertation Council before the open vote, during which the sound of the broadcast is muted about 5 minutes if it is necessary. Open roll call, counting of votes by the chairman of the Dissertation Council with the entry of the results into the minutes of the meeting. Making a decision on awarding or not awarding an academic degree. Concluding remarks of the applicant. Dear colleagues, are there any questions or objections to this regulation? No questions, as well as objections. So I'm starting to conduct the meeting. Sorry. Chairperson's brief report. The dissertation Anna Kuzminova for the degree of the candidate of chemical sciences, specialization 142 analytical chemistry, on the topic optimization of evaporation and nanofiltration processes by creating novel polymer membranes modified with metal organic frameworks, was accepted for the defense by the order of the academic secretary of St. Petersburg University from the 18th of January 2022, number 200/1. Anna Kuzminova wrote her dissertation research on the basis of St. Petersburg University as a postgraduate student. Her scientific supervisor is Anastasia Pinkova. I have already introduced her. The number of publications of the applicant in which the main scientific results of the dissertations are stated according to the list presented: 3 publications. They are published in journals indexed in the scientific databases Web of Science and Scopus. 1 thesis of the report was presented at the conference. The applicant for the degree submitted to the scientific secretary a complete package of documents, and all the documents conforms with the all necessary requirements and are stored in the applicant certification files. Their copies are held by an employee of the Department for Maintenance of the Activities of the Dissertation Council, who is now in the hall. Before giving the floor to the applicant, dear members of the Dissertation Council, do you have general questions to the applicant? And if there is a necessary to announce and consider the entire list of documents submitted by the applicant for the defense? No questions. And now the floor is given to our candidate. Good afternoon, dear board members, colleagues and guests. The topic of my work is optimization of evaporation and nanofiltration processes by creating novel polymer membranes modified with metal organic frameworks. Recently, much attention has been paid to membrane methods, evaporation and nanofiltration, due to the fact that they are good alternative to traditional methods of separation and concentration of liquid mixtures. These methods are environmentally friendly, use compact equipment and low power consumption. The rapid development of membrane methods requires the development of new membrane materials with desired properties. Well-known membrane materials of various chemical nature were chosen as materials for the preparation of membranes. For example, sodium alginate and polyamphylene isophthalamide were used for evaporation membranes, and the polymer with internal microporosity, PIM1, was used for nanofiltration membranes. The choice of metal organic framework structures as membrane modifiers was due to their high porosity, good chemical and thermal stability, as well as controlled chemical properties, which significantly change the characteristics of membranes due to changes in surface properties and free volume, which significantly affects the mass transfer of low molecular weight liquid substances. Mass transfer occurs in the processes under study by the dissolution diffusion mechanism, in which first of one of the components of the mixture being separated is sorbed on the membrane surface. Then this component diffuses through the membrane and desorption from the reverse side of the membrane. Thus, the aim of the work is to optimize the methods of separation and concentration, evaporation and nanofiltration by creating and studying new high-performance polymer membranes modified with the organometallic framework structures to reduce the detection limits of analytes, organic solvents, heavy metals, and dyes. To achieve this goal, the following tasks were identified: to develop methods for modifying known membrane materials with organometallic framework structures, obtain diffusion and or composite membranes, study structural characteristics, to study the transport characteristics in the process of evaporation and nanofiltration, the structural, physicochemical and transport properties of the developed membranes, as well as the compositions of the studied mixtures, were studied by the following methods. Let us turn to consideration of pervaporation membranes. Pervaporation is used to separate and concentrate low molecular weight components from isotropic mixtures, mixtures of isomers, and low boiling substances. The procedure for conducting a pervaporation experiment is as follows. A membrane is inserted into the pervaporation cell, onto which the separation mixture is poured. Pressure is created under the membrane using a vacuum pump. The components that have passed through the membrane are condensed in a trap cooled with liquid nitrogen. The composition of the permeate was determined by gas chromatographic analysis. The transport characteristics in this presentation during pervaporation include specific productivity and concentration factor, which were calculated from the presented equations. To improve the properties of sodium alginate polymer membranes, 3 organometallic framework structures containing MOFs were added to its matrix. Then the resulting mixture was dissolved in distilled water with further ultrasonic treatment. Diffusion membranes were obtained by pouring the resulting dispersion into a petri dish, followed by evaporation of the solvent. The transport properties of membranes made of sodium alginate modified with organometallic framework structures were studied during the evaporation of a water mixture. The slide shows the difference of the specific productivity and concentration factor on the content of MOFs in the sodium alginate matrix during the evaporation separation of an isopropanol water mixture with a water content in the initial mixture. The data presented in the histogram demonstrate that the introduction of the MOFs into the sodium alginate matrix leads to the increase in the specific productivity and concentration of the threshold factor while maintaining high membrane selectivity with respect to water. For the use of AN membranes in the separations of dilute solutions of isopropanol, their cross-linking is required. Cross-linking was carried out by immersing the membrane in an aqueous solution of calcium chloride for 10 minutes, followed by washing the membrane with water. Cross-linked unmodified and modified diffusion membranes were tested by evaporating a water mixture over a wide range of concentrations. All membranes showed high water content in the permeate. The dependencies of the specific productivity and the concentration factor on the water content in the initial mixture presented on the graph demonstrate an increase in these parameters with an increase in the water content in the initial mixture. To increase productivity of diffusion membranes, the selective layer thickness was reduced by creating composite membranes in which a thin selective layer was deposited on a porous polyacrylonitrile substrate. Composite, modified, and unmodified cross-linked membranes were also tested by evaporating a water mixture over a wide range of concentrations. The slide shows the dependencies of specific productivity, water content in the permeate, and concentration factors on the water content in initial mixture. Thus, the creation of a composite modified membrane made it possible to significantly improve the transport characteristics of AN membranes, and also to an increase in the concentration factor up to more than 100% compared with the diffusion unmodified membrane for AN in the separation of isopropanol water mixture with the water content in the initial mixture of 30 WT%. To explain the transport properties of the developed membranes, the physical and physical-chemical studies were carried out. The internal structure and surface morphology of the membranes were studied using scanning electron microscopy. It was found that the introduction of organometallic framework structures and the cross-linking of polymer chains with calcium chloride leads to a more inhomogeneous membrane structure compared to an unmodified membrane. The roughness of the membrane surface is of great importance for the degree of membrane swelling in the test mixture. Changes in the surface of modifying membranes were studied by atomic force microscopy. Images for non-cross-linked and cross-linked membranes are presented on this slide. The next polymer studied was polyethylene azophthalamide. To improve the properties of polyamide evaporation membranes, 3 ZR-MOFs organometallic framework structures were added to its matrix. The resulting dispersion was applied to a glass substrate, followed by evaporation of the solvent. The transport properties of polyamide membranes modified with organometallic framework structures were studied during the evaporation of a methanol mixture. To select the optimal modifier for polyamide, 15 weight% of 3 ZR-MOFs were introduced into PA matrix. This slide shows the values of specific productivity, methanol contents on and permeate and concentration factors for membranes with various modifiers during the evaporation of an azeotropic methanol mixture. It was found that the transport characteristics increase when 15 weight% ZR-MOFs are added to the PA matrix. Further, to select its optimal concentration, evaporative separation of the azeotropic methanol mixture was carried out by means of membranes containing up to 50 weight% of this modifier. It was found that the specific productivity, methanol content in the permeate, and concentration factors increase with the introduction of up to 15 weight%. While a further increase in the modifier in the membrane matrix leads to a decrease in the presented characteristics. To increase the performance of the best membrane from PA modified with 15%, or 66 EDTA, the thickness of the selected membrane layer was reduced by creating composite membranes in which a thin selective layer was deposited on a porous regenerated cellulose substrate. The creation of a modified composite membrane made it possible to significantly improve the transport characteristics of PI membranes, reducing the thickness of the selective layer to 1.5 led to an increase in the specific productivity of the modified composite membrane by factor of 5, and also to increase the methanol content in the permeate up to 93% and the concentration factor up to 102% in comparison to the diffusion unmodified PA membrane when separating the isotropic methanol mixture. To explain the transport properties of the developed membranes, their physical and physico-chemical studies were carried out. The internal structure and surface morphology of the membranes were studied using scanning electron microscopy. It can be seen from the micrographs of the transverse cleavage that the introduction of UiO66 EDTA into the PA matrix leads to the inhomogeneity of the surface of the transverse cleavage of the modified membrane, which increases significantly with increasing modifier content. To explain the mechanism of mass transfer during evaporation, the degree of membrane swelling in methanol and as an isotropic methanol mixture was estimated. The final section is devoted to the study of nanofiltration membranes that can be used to remove heavy metal ions, dyes, pesticides, and bacteria from water and organic solvents. The technique for conducting a nanofiltration experiment is as follows. A membrane is inserted into a stainless steel cell onto which a mixture is poured for separation. Pressure is created from above the membrane with the help of gas. The liquid that has passed through the membrane is analyzed by various methods depending on the mixture being separated. The transport characteristics in the nanofiltration process include permeability, retention coefficient, and concentration coefficient, which were calculated using the presented equations. A polymer with internal microporosity PIM1 was chosen as a polymeric material for the development of nanofiltration membranes. The PMI1 MOFs dispersion was prepared as follows. MOFs and PIM1 powders were carefully ground in a agate mortar. The resulting mixture was dissolved in chloroform with further ultrasonic treatment. Composite membranes were obtained by pouring the resulting dispersion onto a porous industrial substrate UPM20, followed by evaporation of the solvent. The transport properties of membranes were studied in the nanofiltration of pure solvents, a model solution containing food coloring, a colored caramel solution containing food coloring, a model solution containing heavy metal ions, and industrial water containing heavy metal ions. When studying the permeability of pure solvents of water and ethanol, it was found that the introduction of MOF into the PIM1 matrix leads to an increase in the permeability of these solvents, especially for the membrane modified with MIL 140A. Further, the object of the study were solutions of food dyes, alpha-zurine and dye-yellow sunset in ethanol. The graph shows the values of permeability, retention factor, and concentration factor for solution of these dyes. It was found that the modification of MIL 125 membranes leads to an increase in the permeability while maintaining high values of the retention and concentration coefficients, while the modification of MIL 140A leads to a greater increase in permeability but a slight decrease in the values of the retention and concentration coefficients. Next, the concentration of 3 food colors from a real object of dissolved caramel was carried out. The graph shows the values of permeability, retention factor, and concentration factor for a caramel solution containing three dyes. It was found that the modification of MIL 125 and MIL 140A membranes leads to an increase in the permeability, but a slight decrease in the values of retention and concentration coefficients, as in the case of nanofiltration of a model mixture containing 2 dyes. In addition to the concentration of food dyes, the transport properties of membranes were studied by concentrating lead and copper cadmium ions from a model solution. The graph shows the values of permeability, retention factor, and concentration factor for a model solution containing heavy metal ions. It was found that the modification of MIL 125 and MIL 140A membranes leads to an increase in permeability, but a slight decrease in the values of the retention and concentration factors. Heavy metal ions were also concentrated from a real object of raw sewage, which was provided by the galvanic company. Both the original mixture and the mixture diluted 100 and 1000 times were studied. The graph shows that the values of permeability of a mixture diluted 1,000 times, a mixture diluted 100 times, and the original mixture. It has been noted that the permeability decreases as the concentration of heavy metals in the raw wastewater increases. The highest permeability values, as in the case of module solutions, were noted for the membrane containing Mil-140A. Also, for the studied membranes, the retention coefficients were calculated, which were more than 98%, and the concentration coefficients, which were more than 109%. Thus, based on the presented data, it was shown that the membrane modified with Mil-148 has the highest permeability at sufficiently high retention and concentration coefficients in the process of nanofiltration of model and real mixtures. To explain the transport properties of the developed nanofiltration membranes, their physical and physicochemical studies were carried out. The internal structure and surface morphology of nanofiltration membranes were studied using scanning electron microscopy. It has been noted that the incorporations of Mil-125 and Mil-148 into PIM-1 matrix results in a rougher cross-cleavage structure. Non-through pores are observed on the surface of all nanofiltration membranes, the size and number of which depends on the modifier. Thus, compared with the unmodified membrane with the introduction of Mil-125, a significant decrease in the number of pores and an increase in their size are observed, while the introduction of Mil-140A, the numbers of pores decreases without a significant change in their size. An additional study of the change in the surface of the modified membranes was carried out by means of atomic force microscopy and the study of wetting angles with water. Average roughness values were calculated from the image data. The conclusions are presented on the slide. Allow me not to read them out. I would like to attribute the following to the main methods for modifying the structure of various classes of polymeric membranes were proposed, which made it possible to optimize the membrane methods used in sample preparation for the separation and concentration of aqueous and organic mixtures, including complex chemical compositions. That's all. Thank you. Dear board members, your questions strictly according to the report. Anna, please tell me, for membrane which we used for evaporation, did you use the card for composite membranes in order to understand how your MOF particles were distributed there? Were there data only for whole films? For composite membranes, I also studied the morphology of the surface with the help of scanning microscopy. This photo shows the photo of the cut. We see that in the cut we can see the modificates, and this there are no photos in the presentations, but they are represented in my dissertation paper. The second question, slide 36. There is the dependence of watering angle. This minimum. How can you explain this minimum? This minimum can be explained as follows. Particle UiO 66 NH2ADTA. They lead to the hydrophilization of the surface with the help of the increase of roughness of membrane surface. Further increase of modifier led to hydrophilization of the surface. Huge agglomerates of particles formed there. the increase of surface roughness should have increase. It's the next question. The shear effect of surface roughness. Did you assess the interaction of the level of roughness with the current? Because in your case there is an increase of active surface, and I don't mean porous particles. You increase the contact area. I would like to show alginate sodium alginate. When we introduced the framework, the roughness area increased, and the membrane depended on this roughness, and the highest performance had the membrane with high roughness. Thank you very much. Thank you. Are there any other question? Please switch on your microphone. Slide 18, please. Show a polymer chain at the count of the formation of condensed connections. You added sodium chloride, calcium chloride. Did you prove the increase of solution viscosity? How did you prove it? With the help of infrared, MR, microscopy, the blocks were connected in the sodium alginate. With help of MR, it was proved that correlation of stitching was 1:1. Two polymer chains, between them there is a connecting agent. It can lead to the fact that in this reaction will involve three groups from the same polymer chain. But the linking of polymer chains can be proved by sustainability of linked membranes in pure dissolved water. Please, slide 10. It is shown in the slide that the lowest permeability is obtained from the highest concentration of initial mixture. When ions of heavy metals in the initial mixture, we receive the highest absorption of metals, and it impedes the permeability because there are lots of heavy metals. But the sum of heavy metals in dissolved or concentrated solution is the same. If you take dilute solution, the picture will be the same. You see, we have high volume of initial mixture, 300 milliliters. we need to conduct more prolonged experiments. We supported the concentration of ions in initial metals, and how long did it take? The concentration of membranes, 1,000 times. It took 1 day, and every hour we checked it. In another case, it took 6 hours to understand one point. General question. These compounds, framework compounds with zirconium, these are fillers to solve the problem with the greenhouse effect and so on. Did you try to use your systems as catalyzing systems, because they are very active catalyzers? Thank you very much for your question. Catalyzing peculiarity of these modifiers is subject of our current and further study, and these membranes are not represented in my dissertation paper, but we will use them for such systems in our further research. Valentin Georgievich, your question? Yes, I have got 2 questions. First of all, thank you very much for your detailed report. Please show us slide 45. Please close to the microphone. Slide 45, tell us please the permeability for OPM20. There is a mistake. How did you manage to achieve such results? The very left side, it is not for OPM20, it is for PIM1. Thin layer from PIM1 was, it is ultra filtrating platform. We studied 3 membranes. The membrane is very productive and reproductive. The second question, from the analytical point of view, you have got a lot of experimental methods. You used a lot of experimental methods. It is the advantage of your dissertation. You write that that you used. You say that you used nuclear magnetic resonance, and with the help of it we proved the interaction of modifier and polymer. And because we are pressed for time, I did not present them in my dissertation. Whether they are linking of polymers, how do they interact? It is very important. I would like to you to reflect it in your report. Dear board members, do you have any other questions? I have one funny question. What's the difference, structural difference between polymers with internal porosity and membranes of diffusion type with free volume, where there is a transition? Polymer with internal microporosity, it has very strict, tough structure, and when polymer membrane dries, internal structure appears with internal areas. We can see them in the photos. These pores, they are not transparent. They can be considered diffusional. There is no difference. There is a space through which there is a transition. Porosity specificity of membrane preparation. And paraform is without stabilizer. It is known in the literature for PIM, and it has nothing to do with free volume. It is not a free volume. This difference can't be explained with the help of these artifacts connected with evaporation of the solution. You see, any structure can't be described in detail. Against micron. Dear board members, let us continue. Now we have turned to the feedback of board members and their answers to these reviews. Dear Anna, I think that she will answer after each speech of the board members. It will be more convenient. Mr. Ivanets is absent. I will start with his review. Dear board members, as all reviews were published on St. Petersburg University website, I offer you not to read out the whole review. Please focus on the main points, on your remarks, questions, and suggestions. The review of Andrei Ivanets. The topicality, actuality, the dissertation conforms with the requirements of the specialization and the practical and scientific significance of the dissertation. The remarks. There is lack of the stability of composite membranes with thin selective layer with prolonged experiment or under high increased temperatures. Figure 29, the division of the parts is represented in table 9, calculated from the figure of meaning through comma. The same can be referred to figure 34, table 11. Then the candidates calculates the extent of swelling for the membranes on the basis of alginates, sodium alginate and polymer phenylene nisophthalamide with the use of the formulas without taking into account the residual solvents, formula 8, and my remarks are of precise in character, and they don't spoil overall positive impression from the dissertation. Conclusion: the dissertation on the topic optimization of pervaporation and nanofiltration processes by creating novel polymer membranes modified with metal organic frameworks conforms with the main requirements stated by the order from the 19th of November 2021, number 11 11181/1 procedure on awarding academic degrees at St. Petersburg University, and our candidate Anna Kuzminova deserves the degree of the candidate of chemical sciences, scientific specialization 1.4.2 analytical chemistry, chemical sciences. Points 9 and 11 of the order were not violated by the candidate. Andrei Ivanets. Valentin Georgievich, your report, your feedback. I like the dissertation while I was reading it. It is very accurate. The language is very accurate, clear. It's very important study. It is of high practical significance. Scientific novelty is proved in the text of the dissertation. It is very clear, and I was impressed by the volume of experimental methods, and judging from the presentation, they were experimental results, graphs, tables which demonstrated the volume of the study. And of course there are some questions, remarks. I have some questions. Please let me read them out. Why for nanofiltration membranes from polymer with internal microporosity PIM1 and its composites with metal organic framework structures, you did not study optional characteristics of membranes? Then what is the dependence on what does the choice of the way of combining modifier and polymer depend? And for the composite polyamphylene nisophthalamide, they are MOFs. You introduced DMA modifier. And concluding question, you did not explain very well the choice of porous platforms for the creation of pervapораtional and nanofiltrational composite membranes with thin selective layer. What were your criteria for the choice, and does it depend on a membrane process? But my remarks don't spoil overall positive impression from the study. Dissertation of Anna Kuzminova on the topic optimization of the processes of evaporation and nanofiltration by creating novel polymer membranes modified with metal organic framework conforms with the main requirements stated by the order from the 19th of November 2021, number 11-181/1, procedure on awarding academic degrees at St. Petersburg University. And our candidate Anna Kuzminova deserves the degree of the candidate of chemical sciences, scientific specialization 1.4.2 analytical chemistry, chemical sciences. Points 9 and 11 of the order were not violated by the candidate. Valentin Georgievich, thank you very much. Alexey Vladimirovich, the floor is yours. The volume of the work was mentioned. My feedback includes all the questions. They concerns the accuracy of the terms our candidate used. The first remark is referred to the fact the novelty is described generally, but judging from your results, your study could have been demonstrated better. There were some inaccuracies concerning the terms when you wrote that physical and chemical properties of initial mixtures don't influence the process itself, but they do influence the process. Vapor and the material of the membranes and so on. I would like to highlight that you used in your study the data absorptions, but not concerning the changing of size of the sample. You introduce porous particles, general inclination of the sample can create artificial porosity. Absorption influences greatly. Absorption's data due to artificial pores, they were not efficient. One more remark: when you create nano-modification membranes, there were differences, and you did not study the chance of penetration of your material into pores, which could influence the data of parameters. Then, more accurate use of terms. This remark: you did not interpret all the absorption's variance. It is my advice for your further research, and my remarks don't spoil overall positive impression from the dissertation. The dissertation is a very successful completed research. The dissertation of Anna Kuzminova on the topic optimization of pervaporation and nanofiltration processes by creating novel polymer membranes modified with metal organic frameworks conforms with the main requirements stated by the order from the 11th of November 2021, number 11181/1, procedure on awarding academic degrees at St. Petersburg University. And our candidate Anna Kuzminova deserves the degree of the candidate of chemical sciences, specialization 142, analytical chemistry, chemical sciences. Points 1 and 9 and 11 of the order were not violated by the candidates. Thank you. Alexey Vladimirovich, Mikhail Viktorovich, your feedback. Dear colleagues, I like the work. Practical significance, actuality, scientific novelty. First of all, the scientific novelty impresses a lot. Apart from that, I would like to note a huge volume of the material. It's not only a wide range of polymers, it is use of various methods for the research. And our candidate knows these methods at qualified level. There are some remarks concerning the dissertation. Page 46, when preparing these membranes, out of 8% of solutions, polymer film was obtained with the thickness of 50 microns. At the same time, while preparing composite membranes, out of 5 weight %, the solution thickness of selective layer was 1.5 plus minus 0.3 nanometers. Then please explain why in the case of membranes on the basis of alginate, sodium alginates, the base transporting properties had linked diffusion membrane modified 15 weight percent UiO 66 AH plus UiO 66 15%, page 98. Number 3, a list of abbreviations is absent in the dissertation. My remarks of discussive character and don't spoil overall positive impression from the work. On the whole, the work is very impressive. It contains the elements of scientific novelty. The conclusions conforms with the main requirements for the dissertations. The dissertation of Anna Kuzminova on the topic optimization of evaporation and nanofiltration processes by creating novel polymer membranes modified with metal organic frameworks conforms with the main requirements stated by the order from 19th of November 2021. Number 11181/1, procedure on awarding academic degrees at St. Petersburg University, and Anna Kuzminova deserves the degree of the candidate of chemical sciences, specialization 142, analytical chemistry, chemical sciences. Points 9 and 11 were not violated by the candidate. Thank you. And my report. And my report the more the volume of experiment is, the more difficult it to make both ends meet. All the requirements were met. It has scientific novelty, and thus the work is very interesting. It is very important that not only model mixture were used for separation when you study the membrane properties. The practical significance of the work is very high. Scientific mixtures were analyzed. My remarks. When you chose as the object of the research those initial membrane materials which were modified further, you did not explain your choice. The author writes about the study of the membrane structure with the help of infrared spectroscopy and nuclear magnetic resonance method and X-ray diffraction, but in fact here we can say about chemical links characterizing this membrane material, but it is not the structure of membrane material in usual understanding of this term. You don't explain very well the choice of specific pairs of membrane separated mixture for which the influence of modified membrane material was studied. Why in the permeability of anisotropic membrane of type PM20 increases while real sewage water is diluted. How can you explain minimal coefficients of concentrated of the ions when the real sewage water is highly diluted. As for flat needles in structural rather than technological sense, these are plates which can be considered as the analog of two-dimensional structure, but the needle is a sort of analog of one-dimensional structure. For example, as linear polymer chain. And your personal contribution into your work is very impressive. My remarks don't reduce overall positive impression from this study. The dissertation of Anna Kuzminova on the topic optimization of evaporation and nanofiltration processes by creating novel polymer membranes modified with metal organic frameworks conforms with the main requirements stated by the order from the 19th of November 2021, procedure on awarding academic degrees at St. Petersburg University. And our candidate Anna Kuzminova deserves the degree of the candidate of chemical sciences, specialization 142 analytical chemistry. Points 1 and 11 were not violated by the candidate. Anna Igorevna, the floor is yours. Please answer the remarks. I will answer in the order as the reviews are presented at the website. Alexandra, Valentin Georgievich, for nanofiltration membranes made of a polymer with internal microscopy PIM1, this option of characteristics of membranes were not studied, since the membranes were composite and not only a thin selective layer but also a porous substrate could participate in these options of components. The choice of method for combining the modifier and the polymer depends on the quality of the dispersion of the modifier in the polymer solvent. In the case of PA and DMA, a uniform dispersion of MOFs in the solid was obtained, while when the organometallic framework structures were introduced into AN and PIM1 by the solution methods, large agglomerates of particles were visible in the polymer solution. Therefore, the solid phase method of introducing the modifier was chosen due to the fact that a porous substrate is necessary, first of all, to provide mechanical strength to a thin selective and not to separate liquid mixtures. We were guided by the following criteria for its selection. The substrate should have good adhesion to the selective layer, the required porosity to prevent leakage of the solution and the difficulty of mass transfer of liquid substances, good chemical resistance to solvent in contact with it during the preparation of composite membranes and membrane separation, good mechanical strength. In the framework of the dissertation work, porous substrates were used didn't depend on the membrane process being carried out, but depended only on the criteria mentioned earlier. As for Lyudmila Eduardovna, yes, the results obtained in this work can be used to predict the behavior of the developed composite membrane materials upon concentration of analytes similar in physico-chemical properties. Sodium alginate membranes can be used to concentrate various alcohols from their aqueous solutions. Polyamide membranes can be used to isolate methanol from various methanol containing mixtures, and PIM1 membranes can be used to concentrate other dyes and heavy metal ions. An increase in the permeability of composite nanofiltration membranes upon dilution of real wastewater is due to a decrease in the concentration of heavy metal ions in more dilute solution, and as a consequence a decrease in the absorption by a membrane. The flow of the mixture in the cell to the membrane surface is normal and constantly in a dead-end mode with storing the pH of the original wastewater in a dilute solutions was the same and amounted to 5.5. Different concentration coefficients of heavy metal ions and the same mass concentration in the mixture are associated with different rotation coefficients, which may depend both on the nature of the ion itself and on its hydration shell. For the preparation of model solutions, any concentration, including the molar one, could be chosen. Mass concentrations were chosen to approximate the real object, where molar concentrations vary. The minimum concentration coefficients of a number of ions at the highest dilution of the initial wastewater can be explained by the minimum values of the retention coefficients, since the sorption centers in the membrane in dilute solutions are filled more slowly and a small amount of ions has time to pass through the membrane. I completely agree with remarks of Alexey Vladimirovich, number 1, 2, 3, 4, 6, 7, and 8. Let me answer the question number 5. The reproducibility of the thickness of the selective layer from sample to sample was controlled by scanning electron microscopy of the transverse cleavage. The thickness of the P1 selective layer was reproducible from sample to sample and was about I completely agree with Andrei Ivanovich's remarks number 1 and 2. Let me answer the question number 3. Sodium alginate contains a small amount of residual solvent, up to 3%, while in polyamide the amount of residual salt reached 20%. The presence of residual solvent in the polymeric diffusion membrane leads to its plasticization and additional transport channels, causing an increased productivity of PA membranes compared to sodium alginate membranes. I completely agree with the remark of Mikhail Yakovlevich number 3. Let me answer the questions posed. Obtaining the ultra-thin polymer layer was due to the used method of preparing composite membrane in which 5% polymer sodium was poured onto a porous substrate fixed in a ring for 50 seconds, after which the polymer solution was drained and the membrane was dried first in the air and then in the cabinet. The difference in the transport properties is due to the chemical nature of both the polymer itself and the modifier. Upon the introduction of modified organometallic framework structures into the AN matrix, the interaction of functional groups of the modifier and the polymer was noted, which led to the cross-linking of polymer chains and, as a result, to a decrease in the specific productivity of the membranes compared to the membrane modified with UiO66 without additional functionalization. Well, for polyamides, it was the presence of the amino group and EDTA in the modifier that led to the structuring of the polyamide film and the formation of additional channels for the transport of polar molecules, and as a result to the highest values of specific productivity compared to the modified UiO66 membrane. Dear board members, are you satisfied with the answers? Dear those all present, do you have any questions? Would you like to have the floor, please? The first present wants to have the floor. Sergei Remarkov, Doctor of Chemical Sciences, Professor of the Department of Analytical Chemistry, St. Petersburg University, distinguished chairperson, distinguished board members, dear colleagues, ladies and gentlemen. It's very difficult to have the floor after the speeches of all board members and chairperson, who of course explained everything in and discussed the dissertation in detail. I would like to add something. I would like to note the serious character, the broad character of the work. Analytical chemistry was analyzed, and at the same time membrane synthesis, such contradictory things in chemistry. Apart from that, the application in technology for mixture separation was shown. Practically all spheres of chemistry were covered in this dissertation paper. And of course, according to my position, I'm often present at defenses, dissertation defenses. This work is higher, exceeds the requirements for candidate dissertations, and it is a very decent work, and I am sure that our candidate deserves the degree of the candidate of chemical sciences. Thank you very much. Of course. Thank you. Now please introduce yourself. Ilya Leonidovich, leading senior scientific worker of the Laboratory of Synthesis, Russian Academy of Sciences. I would like to ask some questions concerning the dissertation. In one of the slides, there was shown as a conclusion that concentration of water permeate was 99.99%, something like that. 99 for sodium alginate, you mean for composite membranes. It was a mistake. It is and you show graph concentration for different membranes is different. The content of the water in the permeate is the same. The factor of division, the concentration coefficient in pervaporation, the concentration coefficients should be the same. And these are different things. In permeate, it is concentration the separation factors were the same, and it is correlation of concentration for concentrate. The concentration coefficients depends not only of the water content in the permeate. We conducted an experiment. This is production formula. The experiment was as follows. Every membrane was filled with initial mixture and tested for 1 hour. Then we selected the concentration in the results and divided it in the initial mixture. We fixed the initial volume and we fixed the time of concentration. As a result, sodium alginate received less permeate. We speak about selectiveness of membrane, 99.99% in permeate, but in initial mixture was this concentration constant. It was constant. And the study of concentration coefficients required additional experiments. Initial mixture was added. If we divide one constant into another constant, we will receive constant as a concentration coefficient. Here we speak about the concentration as a propanol water. It had from 12 to 100 weight percent. And that's why It increased. Yes, it is will be calculated later. It is arithmetic thing. Do you have any other questions? One more question. I have got one more question, general question concerning the dissertation. You see, you studied from the point of view of polymers, studied famous objects, PIMs, algenates, polyamides. In the literature, gigantic information, a lot of information is presented concerning these objects. And how does your work correlate with the literature you studied, with the literature which exists in the world? I will start with membranes from sodium alginate. The results on transport characteristics contain preserved selectivity, but it is 31 times more of commercial analogies, membranes pervap 1. And membranes in my work, they had improved transport characteristics in comparison to membranes represented in the literature. For the membranes from polymers with internal microporosity PIM1, I could not find for nanofiltration. There are other works where pure PIM is used. If we compare with other modifiers, our results obtained, they were either comparable or better, depending on separable mixtures. But I did not face in the literature when objects are separated. Model mixture were separated. Are there any other volunteers with questions? Are there any external reviews? You did not receive anything via email? Well, our discussion is finished because there are no additional questions. Distinguished board members, we can have the break. We forgot about scientific supervisor. Anastasia Vladimirovna, she's exhausted today. We can talk for hours about Anna, our candidate, but I'll try to be as brief as possible. Anna Igorevna started work in 2017, the first year of master's studies within the period of 5 years. If compared with me, there are 3 works on the topic of the dissertations. The general number of articles is 33 articles in Scopus as Web of Science. She has got a patent. She participated in many international conferences, and thanks to high intellectual abilities, communicational skills, analytical skills, we can speak a lot about Anna. And thanks to the fact that she was a supervisor of 2 grants and participated in 2 grants, 7 grants. She deepened her knowledge not only in our scientific group but also in Topchief Institute. There are high qualified specialists in the sphere of membrane and membrane processes in our friendly team, in friendly Belarus, and in the group Denis Razat. Anna is an independent researcher. She can supervise her own scientific group, independent group, but I hope that she will stay with us in terms of further research. And our discussion is finished. Thus, before discussing the results and concluding voting, dear board members and our candidate, do you have any questions or objections concerning the procedure of the defense, in particular connected with the remote access mode? No objections. Anna Igorevna, no objections. And a question to board members. We have the opportunity before the start of voting to announce a break to discuss the defense results, with the broadcast sound muted. We don't need any additional discussion. We continue our meeting and turn to the voting. Every board member should express his or her opinion. Now it is 2:23 p.m. according to Moscow time. Please, Valentin Georgievich. I raise the question of awarding Anna Kuzminova. We continue our meeting. I am raising the question of awarding Anna Kuzminova the degree of the candidate of chemical sciences in this scientific specialization 1.4.2 analytical chemistry on an open roll call. And point 11. In the dissertation, the candidate for a scientific degree has to refer to the author and the source of borrowing materials or individual results. When using in the dissertation the results of scientific papers performed by the applicant for a scientific degree personally or in co-authorship, the applicant for an academic degree is obliged to note this circumstance in the dissertation. I remind you that this decision of the Dissertation Council on the issue of awarding an academic degree is considered positive if more than half, but at least 3 members of the Dissertation Council who participated in the meeting voted for it in accordance with Clause 23 of the procedure. Valentin Semyonov, your opinion? First of all, I would like to say that indeed, in fact, the dissertation is written at a very high level, and as most part of us, of course, there is a desire to insert all the material into the text of the dissertation. The text of the dissertation lacks informative and promotional character, prospects and so on. On the whole, I am for the degree. I like the work very much. And please, for future, you should create an sort of an advertising. Alexei Volkov, your opinion? The work is excellent and scientific. Advertising, it is a separate topic, the main thing that the work is completed and it is accomplished at high professional level, and she proved her qualification completely. I vote for. Mikhail Goifman, your opinion? Dear colleagues, I think that we heard a very interesting work. The work is a completed study up to this moment, but at the same time I would like to note the main dignity of the work. It opens broad horizons, and there are a lot of things for further study. Biomedical technologies can be used, catalyzers, and many other things. And from my very heart, I would like to advise you to continue your research. The work is of high interest. I support this work, and I will vote for. And me, Lyudmila Yervakova, I have the same opinion as my fellow board members, and this work gives an insight into the future. It can be expanded, the research can be expanded, and the results can be applied in many chemical areas. Dear colleagues and guests, out of 4 board members who participated in our today's meeting, 4 voted for, no one voted against, and no one abstained from vote. Thus, the decision on awarding Anna Kuzminova an academic degree of candidate of chemical sciences in the scientific specialization 1.42 analytical chemistry is accepted. Anna Igorevna, your concluding remark. First of all, I would like to thank all board members to read my work, to study it, to give very precious remarks. And thank you very much that you are present today. I would like to express my gratitude to Anastasia Pinkova that you believed in me some time ago. Thank you very much to the head of the Department of Analytical Chemistry, to Artem Alexandrovich, for your help, considerable help. I would like to express my gratitude to operators, to technical specialists. I would like to say hello to my school chemical teacher, Elena Grigorievna, for the fact that she showed me what chemistry is, and I fell in love in this chemistry. Thank you very much to my family, to my parents, to my family, and to those all present in the hall today. Our congratulations to our candidates and family. The meeting is declared closed. Thank you very much for participation. Please switch off the live broadcast. Thank you.